All right, so we're going to finish out talking about law of sines here, but we're going to talk about the special situations where you have side-side angle. In the first video, we talked about angle, angle, side, and angle, side, angle, which we did some examples of those. So you can refer back to the first video if you need help with those. But this is going to be specifically where you're given two sides and an angle that's not in between. This table kind of helps us determine how many triangles that we're going to have, because it is possible that you could have no triangles, one triangle, or two triangles. And it all depends on the situation of the sides and the angles. So the first thing you're going to ask yourself is alpha acute or obtuse? So if it's obtuse, I wouldn't even mess with this table. I would just go through and try and solve it. You will run into situations where maybe you couldn't get the trig function to work, it's greater than 1, and then it's no triangle, or you work it just fine and you get your one triangle answer. But if A is acute, then we have to kind of pay attention to what's going on here. So if A is acute, the next thing I'd check is, okay, is side A greater than or equal to B? If so, I've got one triangle, solve it like normal, I'm good to go. If not, then I have to come up and refer to these formulas. And that's where it tells us what H is right here. So H equals B, side B, times sine of alpha. And then we're going to plug our H's and our A's and B's into this to determine which of these three situations we have. So let's do this example here. I'm going to come back, I'm going to copy this. I'm going to go ahead and get rid of this triangle. All right, so if I'm looking at this, alpha is acute, so I know I'm in this one here. So now I'm going to check. Okay, is A greater than or equal to B? A greater, so no, it's not this situation. So now let's try and figure out H. All right, so H is going to equal B, which is 2.3, times sine of alpha, which is 34. And now I'm actually going to do that calculation. So 2.3 times sine of 34. And I got H to be 1.286. So now I'm going to compare. Is A bigger than 0? Yes. And is H bigger than A? Yes. I can see that right here. So H is bigger than A. A is smaller than H. So right here I can see, hey, I have no triangles. So I don't even need to do any calculations. I can just type in no triangles here. And that's my answer. There's no way to make a triangle out of it, so I'm not going to try. If you wanted to go through and work with your law of sines and try it, that's fine. The issue you'll run into is you'll get sine of beta to be bigger than 1, and you can't solve that. All right, so let's look at this one. All right, is alpha acute or obtuse? It's acute. So once again, I'm in this situation. So now let's look at A and B. Well, A, is it greater than or equal to B? Yes. So I'm only going to have one triangle. That means I can solve this just like normal using my law of sines. So let's just set this up. So I'm going to have sine of 47 over A, which is 3.7, equals sine of beta, because I have B, over 3.5. And then I'm going to go ahead and solve these out just like I would solve any proportion. So 3.5 times sine 47, and I'm going to take that divided by 3.7. So I get sine of beta to be 0.692. So I'm going to do sine inverse of that to actually get that into an angle measure, and I get beta to be 43.8 degrees. Which means now I can find gamma because I've got two of my three angles. I just need to do 180 minus that 43.8 and then subtract out the 47 as well. So I get gamma to be 89.2 degrees. Now I'm going to use this to determine C. As much stuff as we can leave in the calculator, the closer to exact we'll actually have. So just be very careful of how you're typing things in the calculator. Once again, I'm going to set up my baseline proportion, which is a sine 47 over 3.7. And then I'm going to set up my sine of 89.2 over c. But if I have my exact value of this in the calculator, I'm going to go ahead and keep that there. That would be much more handy to what I need to do. So sine of that 89.2 times 3.7, and I'm going to divide that by sine of 47. And then I can find c, and I get c to be, c is 5, and see, these have gone to 1, so 5.1 feet. One triangle, because of how I compared these right here, so one triangle, here's my answer. All right, let's do one more example. Yeah, we don't need that. Okay, once again, alpha is acute, so now I'm going to compare it. Is A greater than or equal to B? No, A is actually smaller than B. So I know, I can see right here that A is smaller than B, but let's go ahead and find our H just to double check. So H, if you recall, is B, which is 18, times our sine of 26. And I get this to equal 7.89. All right. So coming up here, does our A equal our H? No. Is A smaller than H? No. All right, so we already knew that B was bigger than A, and now is A bigger than H? Yes, so I'm going to have two triangles here. And I do want to point out to you that it's going to be the beta that's going to have our main part that we're going to be working. And that's because this angle right here is beta, but also this angle right here. And being very careful, notice these two angles, they're actually supplementary, which means they're add up to be 180 degrees. And that's going to come in very useful here. So I'm actually going to make a copy of this because I'm going to have two versions of this. In this version, so I'm going to go and label, I have triangle 1. And I'm going to have triangle 2. Now we're going to set up and solve, and then there's going to be a special way we find triangle 2. But let's go ahead and solve for beta first, because that's typically our first one we solve for, and I do have, that's the measurements that I have. So I'm going to have sine of 26 over 11 equals sine of beta over 18. Then I can do my cross multiply. I'll end up with sine of beta to equal something here. So 18 sine 26 divided by 11. So I get sine of beta to be 0.717. If you're calling back to the previous chapter, chapter 5 stuff when we're solving the equations, remember sine is our y value. So these two things have pretty much the same y value. One beta will be this, the other beta will be this. So once again, like I said, it's 180 degrees minus this original angle. But let's go ahead and figure out what this beta is. So our first beta, write it in here, is 45.8 degrees. In triangle 2, if you don't want to remember where it's all at, just remember this is going to be 180 minus our beta from triangle 1. I'm going to just write this as a formula here. Let's see if we can make this a little bit smaller. So, like I said, it's 180 minus our beta from triangle 1. Well, our beta from triangle 1 is 45.8. So I'm going to do 180 minus that. 180 minus our 45.8. And we're going to get this to be 134.2 degrees. Change all that. Change this back. Okay, just kind of separate our colors here. All right, if I know my betas, I can find my gammas because once again, I've got 2 out of my 3 angles. So remember, all triangles add up to be 180 degrees. So all I have to do is do 180 minus those other angles, and I will have these angles here. So like this one's 108.2 degrees. And this one is going to be 19.8 degrees. And then I'm going to set up and find the gammas. And keep in mind, this black numbers that we started with here, so our alpha, our A, and our B, that is true in both triangles. So I can still use all of this stuff. So I'm still going to set up and use my sine of 26 over my 11. That's going to be kind of my baseline thing here. But now I've got to come over here and do 2 different triangles. So I'm going to have sine of 108.2 over my C in triangle 1. Then I'm going to set up, okay, so I'm going to use sine of 26 degrees over 11 again. But now I'm going to set up, and it's going to be sine of 19.8 over my C in triangle 2. And you're going to go through and actually do your cross multiplying, your calculations. You'll figure these out. We've been doing them for a while now. So starting with triangle 1. And like I said, if you have a nice calculator that allows you to keep everything exact, that will be really, really nice for you. So our first measurement over here will end up being 23.8 centimeters. I'm running out of space. And then our measurement over here, if we can keep things exact again, will be 8.5 centimeters. So, and that's how we find it if we have 2 different triangles that we're trying to solve for. So hopefully this wasn't too confusing. Just do your best, and good luck with all the homework.